Karule Herbert, your hand is up. What's up? Yes, members, we are getting started now. I welcome you to this online class. I greet you all. I'm Kakulu Bernard, going to take you through this class in Geography Paper 1. Who can remind me of what we looked at last time? You can raise up your hand and remind me of what we studied last time. Yes, Teddy. Teddy, talk to us. Those who were not here last time, we looked at the structure of the Earth. So today we are continuing with the Earth and its planets. Can you see my screen? Alvin, can you see my screen?
Yes, I can see.
Okay, so I'm going to play a video that will dive us into the Earth and its plates topic. So watch carefully and then we can share some lessons from it. Can you see my screen?
Yes, sir. I can see the video thing.
Welcome to Moo Math and Science and the major and minor tectonic plates. There are 7 major plates that make up most of the 7 continents and the Pacific and Atlantic Ocean. A major plate is any plate with an area greater than 20 million kilometers square. The 7 major plates are the African plate. This plate is flanked by the Red Sea Rift, where the Arabian plate is moving away from the African plate. The Antarctic plate. Antarctica has few underwater volcanoes and earthquakes rarely occur in Antarctica. The Indo-Australian plate. The Indo-Australia plate is a major plate combining the Australian and the Indian plate, where they are widely considered to be 2 separate plates. The Australian plate pushes into the Pacific plate along the country of New Zealand, causing violent earthquakes. The Indian and Eurasian plate began colliding into each other, lifting the Himalayan mountain range. The North American plate. This is the Earth's second largest tectonic plate behind the Pacific plate. It extends east to the mid-ocean ridge and west into eastern Siberia. The plate includes both continental and oceanic crust. The Pacific plate, which is the largest tectonic plate, and it includes the hotspot which form the Hawaiian Islands. South American plate. This includes the continent of South America and also includes part of the Atlantic Ocean seabed. The Eurasian plate is a huge landmass with the traditional continents of Europe and Northern Asia. In addition, there are 8 minor plates. A minor plate is any plate with an area less than 20 million kilometers squared, and they are the Arabian Plate, the Caribbean Plate, the Cocos Plate, the Juan de Fuca Plate, the Indian Plate, the Nazca Plate, and the Philippine Sea Plate, also known as the Filipino Plate. These huge tectonic plates continue to shape and form our Earth. Thanks for watching.
Okay, hopefully you've understood what was in the video. We have seen those plates, right?
Yes.
Okay, who can read for us this slide and we proceed? Any person ready can take us through here. Alvin, your audio is on. Could you read for us what you can see on the slide?
The Earth and its plates. A plate is a portion of the Earth's outer layer consisting of crust and topmost mantle. So, consisting of crust and topmost mantle moves as a unit in response to convection in the mantle itself. By mere physical observation, most of the Earth seems inactive and unchanging, but in some places, e.g. California, Italy, Turkey, and Japan, the Earth's crust is dynamic and therefore able to move proceeding Earth's processes and forces, e.g. earthquakes.
Okay, thank you very much. I hope everyone can see my screen. Clear? So we have seen what a plate is. We have defined a plate and we have seen different plates of the Earth. Some of us might have covered this topic, but at least I'm sure you will have a better understanding of this topic, the Earth and its plates, the origin of the Earth and the rest. Okay, let's continue to another slide. Who can take us through this slide? I hope you are taking note in your books there. Yes, Herbert.
Yes, I don't know the question.
It is not a question, but we are requesting you to read for us what you can see on the slide.
Yeah, the Earth and its plates. It's like these regions and other mobile areas lie on the major earthquake zones, most of which run along the middle of the ocean basins, although pass across continental land masses. For example, Alpine Himalayan belt.
Alpine Himalayan belt.
Yeah. Therefore, the Earth crust consists of several large rigid plates, and the movement of these plates produces the Earth's major structural features, e.g., mountain ranges, mid-ocean ridges, trenches, and large faults.
Okay, thank you very much. We have looked at the what a plate is. Then we are saying that by mere physical observation, most of the Earth seems inactive and unchanging. But in most places, e.g., those places, the Earth is dynamic and therefore able to move. So when we continue here, we are looking at those places that are moving. Where we are experiencing too much earthquakes, those are the active zones that show that the Earth is really in motion. When you look at the Himalayan belt, there are a lot of processes taking place, meaning that the Earth is mobile and active. Therefore, the Earth crust consists of several large rigid plates, which we have seen in the other video. We shall continue to see them. And so this means that because of the movement of these plates, we are seeing structures or features being formed, such as mountain ranges, mid-ocean ranges, trenches, large faults, and the rest. We continue. Someone else take us through this slide. Manuela, can you hear me? Unmute your microphone and speak. You can take us through this slide.
Stable
Any other
areas.
person? Okay, Herbert, take it on. Okay, we are saying that stable areas with few or no earthquakes or volcanic eruptions are positioned in the middle of a plate, whereas active areas where rock structures are constantly being subducted or created are situated along the plate boundaries. Active zones of subduction, where the plates are being compressed and rocks destroyed, are off the coast of Japan, California, South America, the Caribbean, and New Zealand. So here we are seeing those active zones where earthquakes are happening now and again, volcanic eruptions are happening. But then in those plates where there are no earthquakes, there are no volcanic eruptions, these places are more stable. That is the difference. So why are these plates stable? It's because their boundaries or on the edges of those plates, that's where the processes like earthquakes and volcanic eruptions are happening. But on those plates where these processes are happening within the plates, you will find that they are being destroyed because of those zones being active. We continue to another slide. Any question before we can proceed? Unmute yourself and speak. More to that, we are still looking at Earth and its plates. Active zones of expansion are in the mid of both the Indian and Atlantic Oceans, characterized by ocean ridges. So in situations where you find that this is an ocean, you can find that in the middle there is a small mountain. It has a valley like that, like that, like that. And these are the ones we are calling the mid-ocean ridges. So you find that that is the floor of the ocean, then something like that is created, like that. And then you find that that is what we are calling a mid-ocean ridge. Like you find there is a valley within the floor of the ocean. Is that clear? Then the main plates and their boundaries are shown below. Where plates meet, those are destructive boundaries, and where they move in opposite directions, those are constructive boundaries. So we are going to look at that map that is showing the active zones and those zones that are stable. So when you look at that drawing, here we are looking at those places that are stable, those that are very active. So when you look at these plates, like how the video was illustrating the different plates, the African plate is very stable compared to other plates. For example, when you look at this, when you look at that point, these are taking in different directions, meaning that here they are ocean ridges, where you find that forces are taking in different directions. That means that there is expansion anytime. Then these ones that are coming together, anytime they can build mountains and the rest. So you can look at them, destructive and constructive. So these ones that are coming together, they are constructive. Then these ones are destructive. Do you get that? Colleagues, are we together?
Yes, sir, we are together.
Okay, so from here, can I have questions? Anyone with questions, you can raise up your hand or you type in the chat. Top right, the man is showing you can raise up the hand, or top left, you type in the chat. Meaning that we are together. Okay, so now we want to look at the origin of the earth. The origins of the earth, especially those different theories. And then we beat up them. So who can read for us this slide? A volunteer.
Hello.
Yes, we can hear you. Take it on.
The origin of the earth. The ways the earth came into existence has been and is still a matter of debate among the scientists. A number of theories have been advanced to explain how the earth came into existence. A theory is a statement or group of statements established by reasoned arguments and intended to explain still needs proof, but nevertheless, it appears reasonable.
Thank you, Noah, for taking us through the slide. So we want to look at those different theories that were put down by different scientists trying to explain how the earth came into existence. Do we know some of these theories? Can you raise up your hand and tell us some of these theories? Or you can type in the chat. Yes, Arvin.
The Big Bang Theory.
The Big Bang Theory, right? Carole? Unmute and speak. Arvin, do you have another theory?
Religious theory.
No, come again.
Religious theory.
Okay, the Bible theory. That's cool. Okay, let's dive into them and explore more about them. So some of these theories, we have the dust cloud theory. We are going to watch a small video that is explaining more about the dust cloud theory. Then from there, you will have understood how the earth came into existence by dust cloud theory. Is that okay?
Yes, sir, no problem.
Tell me you can see my screen.
Yes, teacher.
Yes, sir, you can.
Okay, let's start the watching.
In the beginning came the creation. Time, space, matter, and energy were born. The early stars were formed. When their fuel was used up, the ancient stars died, some violently, leaving vast clouds of interstellar gas and dust. One of these clouds lay dark, cold, and silent for a very long time. Then, over 4.5 billion years ago, it began to collapse, perhaps triggered by the explosion of a nearby star. The cloud was pulled inward by its own gravity into a flat, spinning disk. At the center, a star began to form. From the leftover matter, planets were taking shape. Finally, the new star flared into life. The miracle of creation had begun anew. Now, 4.5 billion years later, a new miracle has evolved. Intelligent life, reaching out beyond the planet of its birth. In this golden age of discovery, we have seen worlds of infinite wonder. This is the story of these worlds and the star that rules their lives. This is the story of our amazing solar system.
Okay, can we share some lessons from that video? What have you got from the video? Raise up your hand and share with us. Hopefully the sound was clear. Yes, Bruce, can you talk to us? Rosie, can you talk to us? Unmute yourself and speak. Teddy, are you able to speak to us? You can unmute and talk to us. In the chat, I think someone was also trying to tell us some of other theories. Someone is telling me to speed up. Sure. Okay. So all that was about the dust cloud theory. We want to move to another theory. If you want to write about it, I'm going to share some small notes in our group. You can continue and write more about the dust cloud theory. We are going to another theory. Which theory is that?
The Bible.
Someone wants the Bible theory. Let's look at the Big Bang theory. Let's first look at the Big Bang theory. Is that cool?
Yes.
Okay, so I'm sharing screen again. tell me you can see my screen?
Yes, sir, we can see. Backside slide, the data is calculated according to the time.
Remember, the Big Bang Theory says, out of nothingness, there existed something, right? So let's continue. Hopefully you have seen how different materials are coming together into the center by centrifugal force. Okay. Members, let me know if you can hear the sound. Some members are saying they can't hear sound. Is it all of us?
No, someone else can hear.
Okay, let's proceed and finish. We can see that the earth is now starting to take shape. Okay, have you seen that? How the Earth came into existence by the Big Bang Theory? Yes? That is to do with the Big Bang Theory. We have seen different particles splitting, then going far distances, and then coming together, and later they had to form the universe. Okay, let's dive into another video. If you want the details of the Big Bang Theory, I will share the content in our WhatsApp group. Basically, the Big Bang Theory was put forward by Georges and Hubble Edwin. That was around 1927. So that's how they proposed that the Earth started 15 million years ago. And so it was from a speck of matter that we saw that started expanding and until we got the Earth. So, but here the wonder still remains, how nothing could produce something. Let's briefly look at the Bible theory. Most of us know about it, and other theories. So let me share screen again. So we have so far looked at the dust and cloud theory, the Big Bang theory. I want us to dive into the Bible theory. Then the theory of Kant and the rest of the theories, we can read them on our own. I will share the work on our WhatsApp group. We continue to understand of this. I will share more of those videos and we continue. Anyone with a question so far? Think none. I'm going to share another video. Is my screen clear? Can you see my screen?
No.
Okay, let me share again. Can you see my screen?
Yes.
In the beginning, God created the heavens and the earth. The earth was formless. In the beginning, God created the heavens and the earth. The earth was formless and empty. Darkness covered the deep waters, and the Spirit of God was hovered above the surface of the waters. God said, "Let there be light," and there was light. God saw that the light was good. Then he separated the light from the darkness. God called the light day, and the darkness night. Evening passed, and morning came, marking the first day. Then God said, "Let there be a space between the waters, to separate the waters of the heavens from the waters of the earth." God called this the sky. Evening passed, and morning came, marking the second day. Then God said, "Let the waters beneath the sky flow together into one place, so dry ground may appear." God called the dry ground land, and the waters seas. God saw that it was good. Then God said, "Let the land sprout with plants, trees, and trees that produce seeds that grow fruit." And God saw that it was good. Evening passed and morning came, marking the third day. Then God said, "Let lights appear in the sky to separate the day from the night. Let them be signs to mark the seasons, days, and years. Let these lights in the sky shine down on the earth." God made two great lights, the sun, and the moon. Then he painted the night sky with stars and saw that it was good. Evening passed, and morning came, marking the fourth day. Then God said, "Let the waters swarm with fish and other life. Let the skies be filled with birds of every kind." And God saw that it was good. Evening passed and morning came, marking the fifth day. Then God said, "Let the earth produce every sort of animal, each producing offspring of the same kind." God saw that it was good. On the same day, God said, "Let us make human beings in our image, to be like us. They will reign over the fish in the sea, the birds in the sky, and all the animals." So God created human beings in his own image, a male and a female. God blessed them and said, "Be fruitful and multiply. I have given you everything that has life." Then God looked over all he had made, and he saw that it was very good. Evening passed, and morning came, marking the sixth day. On the seventh day, God had finished his creation, so he rested from all his work. God blessed the seventh day and declared it holy.
Okay, hopefully all the theories were clear so far. And remember, we say that there are many theories and scientists are still making more to trace the origin of the earth. But most of you who are Christians, most of us normally go with the Bible theory, where we acknowledge God as the creator of the universe. So those are some of the theories. To know more about the Bible theory, you will still read on the document I will send. But basically nothing much. We see this in Genesis 1, where God was ordering for everything to happen, as we have seen in the video. In the chat, I see someone is asking about in the chat, someone is asking where does the Wiggins theory belong? So the Wiggins theory belongs to the continental drift. So it means that after here, we want to see the origin of different continents, the origin of the earth. So these theories happened before the continental drift theory. So from here, we shall see the continental drift and different theories that were raised by many scientists. Okay, so someone is asking, so where does these theories belong? These ones belong to the origin of the earth. Is that okay? And someone is requesting that I may send a summary. Yes, I'm going to do that shortly. Immediately when the lesson is done, I will share the recording and the notes. Okay, more questions entertained in the chat or by raising up the hand. Okay, let's wrap up everything. In today's lesson, we are basically looking at, we have basically looked at the earth and its spreads. We watched a video about the earth and its spreads. We have continued to look at the origin of the earth, where we have looked at different theories. Who can mention them? Who can mention a few theories? At least 4. Who can mention at least 4 theories? Yes, Elizabeth.
Well, there is the Big Bang Theory, the Bible theory,
Okay.
Cantor's theory, and the dust cloud theory.
That is okay. Marvin is asking, can you assist us with questions of any topic? I'm going to do that still in the WhatsApp group. I'm going to share that shortly. Okay. So, in conclusion, a number of theories have been advanced to explain how the Earth came into existence. These include the dust cloud theory, the Big Bang theory, the Bible theory, the theory of Kent. You need to read about the theory of Kent, the Raporis hypothesis theory, and the theory of Chamberlain and Morton in 1904. I will share a summary of these theories. You can read them at your time and understand them. Okay, so I would briefly talk about our services and those who would like to continue studying with us. Yaaka Digital Learning Network. You see a question in the chat. Teacher, mainly the question of the topic we have covered. Yes, I will do that. I will do that. I will supply that question. So here we have services that Yaaka offers. We have online classes where you will keep meeting teacher as you interact like the way we are doing. In addition to that, we have to give you a course. We have to give you a course on the site that includes all the subjects that you study at yaaka.cc. So teachers will have to mark your subjects, they grade, they give you back results at 500,000 for online classes. If you can't manage 500,000, you can subscribe to educare.bz. You read 2 days free access, 1 month 20,000, 3 months 50,000, 6 months, that is half a year, 70,000, and the full year at 100,000. The content we are talking of is multimedia. It has videos, it has images that are well researched, and interactive content where you find that there are some automatic assignments. When you answer them, you get feedback immediately. That is interactive content and the rest. If you can't manage that, you can buy subjects that I can call downloads. One subject is at 10,000. Then if you want all subjects for your combination, that is at 50,000. So visit yaaka.cc or educare.bz for more information. So thank you very much for listening and your active participation. Catch you in another lesson. Someone is asking, no data charges after paying subscription? Of course, you have to keep catering for your data. That's why we don't want to put many lessons, because we know data is also another challenge. That's why we need you to have access to the course. Then you organize with the teacher to set up some classes. Okay? So these classes shouldn't be like a normal classroom where you meet 3 hours. So it should be self-paced. You study anytime you need, whether it is at night, because our subscribed students even study at around 8 p.m. at their convenience. So even we don't have a timetable, but at least each of the students is catered well. Okay, I think I thank you for attending, your active participation. For those who participated, those who didn't participate, next time do better. Have a good evening. Those doing literature, we are going into literature from this lesson. Bye-bye.
When is the next lesson?
It's right now.
Next lesson, we are going into literature by another teacher. So then
like the jog lesson.
The jog lesson. Of course, the week is ending. The week is ending. When you look at the timetable, This is the general timetable. I told you we run classes from P1 up to senior 6. So this is the general timetable. And now you're going into literature. So that's the teacher to handle you into literature. Then tomorrow, those doing physics will be catered. And those doing economics, don't miss. So whenever there is no class in that subject, the timetable is here. Tomorrow is Saturday. Those doing economics, look at this column. You see that column? Economics is here. That means that econ is at 1. Is that clear to you? So that means that times when senior 5 has no classes, other classes are studying. Think I'm clear there. Other subjects that are not on the timetable, we are planning for the next weeks to put some of the subjects.